Welcome to Almon Inc. Industry Training Fundamentals. I'm Nico.
And I'm Keith. Today we're covering topic 1 in our industry training fuse fundamentals. By the end of this video, you will be able to describe what a fuse is and why fuses are important, identify the core components of a fuse,
and understand the difference between several fuse types.
So what is a fuse?
A fuse is a device designed to introduce a measure of safety into an electric circuit. Fuses are installed into a circuit and have an element that melts or blows in the event of overcurrent, opening the circuit and preventing the overcurrent from causing damage and fires.
All fuses are constructed with the same basic components to perform the required function, with differences in how these components are designed based on application. These are the basic common components of a fuse.
Fuse element. The component of a fuse that is designed to melt or blow when overcurrent occurs, opening the circuit and preventing the flow of electricity. Some elements may be resettable to allow the fuse to be reused. Housing. The conductive components of a fuse are surrounded by housing of non-conductive and non-combustible material such as glass or plastic. The housing is usually transparent, allowing inspection of the fuse element. Terminals. Conductive components that complete the circuit and allow electricity to flow through the fuse. Terminals are designed to allow the fuse to be installed into a socket or holder.
Fuses come in numerous different shapes and sizes to suit many different needs and applications. The most commonly encountered fuses are cartridge and blade fuses, which are widely used in common DC electrical and automotive applications. A few other types of fuses are
Rewirable fuses. These are low voltage fuses that fit into a porcelain base. They're easy to replace with low risk of shock.
subminiature fuses. Small fuses found in most modern electronics typically are not resettable or replaceable, soldered directly to a board.
Thermal fuses. Thermal fuses are designed to blow when a specific temperature is reached. These fuses are commonly found in high heat appliances such as hair dryers and toasters. As a general rule, almost every type of electronic circuit will have some type of fuse element. It is extremely unsafe to operate an electric circuit of any voltage without a fuse, as the risk of component damage and fire is increased dramatically. Here are some applications where fuses are regularly encountered and replaced. Automotive. Both the cabin and engine circuits are protected by fuses.
Household electrical. Circuit breakers and breaker outlets work similarly to fuses to protect home circuits.
Electronic devices. Devices such as radios, TVs, and computers all have internal fuses.
Tools and appliances. Power tools and many home appliances have internal fuses to protect the equipment. Some of these may be thermal fuses to protect against high temperatures. This concludes topic 1 of fuse fundamentals.
If you like the content in this video, you can learn more about fuse fundamentals in our Almon Inc. industry training course. That includes theory of operation of a fuse, maintenance considerations, with interactive animations and assessment questions.
Contact us to learn more about this and many other courses by using the link below in the description.
Thanks for watching. Make sure to like and subscribe to our channel to view more training videos.